So let's just start by setting up the mesh like we did before, because since the file broke down just now, we just remove it so that we just have one surface, and we can use or we can just write mesh to turn it into a mesh. We can go for fewer polygons most likely, and just bring out the mesh part, right?
And if we simplify meshed, or we have to re-simplify it.
So we use reduce mesh to simplify it. I mean, you can go up, like for instance, what we're printing now is a mesh that isn't reduced, so it's really this one. But by just looking, I think we can go down to around 10,000 and still more or less keep all of the kind of features of the model without kind of losing any detail. So it is a bit of a compromise between speed and whatnot, but in general, it's usually doesn't make that big of a difference. So it's good to reduce it just in case, and as long as it's not like millions upon millions, or maybe several 100,000 perhaps, then it should be fine. We talked about this before, but I mean, obviously this one is too big. So when printing it later, we're gonna have to make it smaller or something, or divide it up. Right now I do 0.5. Yeah. And we can also consider that if we have it on the bottom, as we did now, it's a little bit easier to add more supports down here. But if we need to add supports up here, then it becomes a bit more complicated. It's still possible, but then you have to use, for instance, create surfaces up here and then use the base geometry to kind of split it or something. And so it's a bit annoying. And the thing with supports in general is that supports, if you do manual supports, you probably want to do them pretty tightly, because its ability to do overhangs is pretty bad in general. Also, if you have intersecting geometries, you're probably gonna get like a smudge line, where it's like all the materials are getting compressed over. Either way, once you're in here, you can open up the script. In this furthest end here of the script, you can find the printing bed, so you can bake it if you want something to, be able to snap the model to. So I tend to lock this and then it's usually better for the print not to be totally flat against the ground, so you can just move it up like 2 meters. It can be worth double checking that the model is for sure that it's like truly planar. As you can see here, it's because we did reduce mesh, so it's a little bit jaggedy now in the bottom, and that can actually at times create issues. So an easy fix would basically be to just add a surface and maybe like move it up 3 millimeters or something, and then cut it and then move down a millimeter or something like let's just we can just try this one and put it in. So just basic things. It's the script. It's in Grasshopper, obviously, and the only parts that you need to really know about is how to put your the mesh into the script. So it's basically this part over here, and give it a special color if we want to, but and maybe like green or something. And more or less everything else is automated or preset settings. There are some things that you can have a look at or we can go through, but basically that's all you need to know. So we set one mesh, and we actually made this mistake before, but you can only use one mesh. But if you want to do, if you have multiple meshes that you want to print at the same time, you just join all the meshes together, and then we can basically put it in as one mesh, and then everything works fine. And if you hide this, then we can see how it's slicing. So basically we have one part back here. This is how we're setting the first layer height somewhat, and so you don't need to touch that. Here is basically the distance between the layers. You probably don't need to touch this either. I think it's fine as it is. We can play around with that at a later date. Then we also need to adjust the flow rate. And here is the amount of brims. So this one can actually be somewhat useful. So we can add more brims to the model. And brim is basically like extra lines in the bottom that just helps the 3D print get stuck, stick to the print bed. Here's the offset, and 6mm should be fine. Now, in general, this part over here, it sets where the endpoints of each print is. So currently, so basically here you can see kind of this print ends here and then it starts over here. So this specific pattern becomes very like Christmas tree like. And we have placed all of them in different spots, mainly to just remove having one seam where everything is in the same spot, because it just makes the print a lot weaker. And I mean, there are a bunch of little things to script that just helps you in general, but the main things are, for instance, this part that that kind of snips the ends of the prints, or this other part that controls the feed rate, for instance. But most of that you don't really need to touch. So the only other part that is relevant actually is over here, where you see this PRC simulation tool, or the PRC settings. And we can go into this by double clicking it, and we get this panel here. Inside of it, we find a bunch of settings. You will most likely not need to change anything, but the only thing that's useful is this analyze tool. Using this, you can see where you might hit singularities, and right now we don't have a lot of them. And we can, for instance, play this simulation as well to see how the robot arm would move. This can be quite useful. It's not always the easiest thing to just see where the lines are.
What does it mean to hit singularity?
A singularity is the end point for a robot arm's axis, and it it's hard to explain exactly why it's called singularity, but I think it's basically that it's coming closer and closer to the kind of maximum range of how far that axis can go. And I suppose singularity is then referring to it getting like close to either, like if it's like it's probably referring to it getting close to the limits, basically. So if we hit a singularity, practically speaking, that would mean that the print couldn't be continued and would have to restart, which would be annoying. The second part is this name part. So here we can change what name the print file should have. So we can call it top test. Okay. And right, and this last part here is that you have to set where to print this thing, and you set it by going to output directory and then pressing browse, and then you can pick whatever you want. Don't forget that you need to press apply for anything to be applied. And once you're ready, it's just pressing this button to save it. To see how long it's gonna take, it's basically this part. We will move it to over here in the next one. So here it says 1 hour and 50 minutes. So that's approximately how long it's gonna take. This is a very rough estimation, but it should be pretty close to truth. And yeah, I think that's most of the important parts. So it's not more complicated than that. And at the end of the day, we'll have to do some. We'll still have to check the file and whatnot. Right. There is one more part that is quite important, and that's under advanced here. To run this, you're gonna need a license. I'm gonna put up that license on Canvas so you can get access to it. And then it's just basically install license, and then you pick the file, and then it should be fine.
And it's just saving the SRC file. There's no option for other files.
Yes, it just saves a SRC file. We could actually have a look at a SRC file. Let's see here if I can find one really quickly. So here, if we open up a SRC file, first in the beginning, you're just gonna see that it sets a few different parameters. For instance, it can be, for instance, the different speeds and starting positions and whatnot. And here we can see, for instance, the kind of linear speed, and I believe the robot arm, if it's 1 meter or 2 meter per second, it's max. But I think that's basically what it's gonna, how fast it's gonna go when it's just going from point to point when it's not printing anything. And then you basically get to the part that is about the code. And here we can also see, for instance, the velocity. I believe this is velocity, and so this is basically speed. Then you see the x coordinate, the y coordinate, and the z coordinate. And then these parts are about rotation. So how the robot arm is supposed to be rotated at this part. And then you have this part that is about extruding. So here we can see that it's at -30, and then it goes up to 200, and then it goes back a little bit because it's just in one line, and then it prints a little bit here, and then so you can just kind of like follow how the print goes by looking at E1 basically. And that's how much it extrudes. So here you see a constant kind of increase of the E1 value.
Is it millimeters
The XYZ is in millimeters. ABC should be in degrees, and then E is its rotations or something like that. So it's or if it's millimeters of rotation, it's a bit of a weird number. So I'm not entirely sure, but yeah. But E1 is a bit more finicky in that sense. So we have figured out a general value for it, but it's not as clear cut, so to say. Yeah.